Hello again, students. I wanted to go over page 243, numbers 1 through 5. This is 25% of your homework, so let's take a look here. Number 1, it says, graph each of the ordered pairs. Use words to describe the pattern shown in the graph. Okay, sweet. I already graphed these on our notes here. So number 1, it gave us 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. So it looks like as y increases by 1, x also increases by 1. The one to the right changes in height. Remember, I've talked about that before, so you better write this thing down. 1 to the right changes in height. So as we go 1 to the right, we are changing our height by a positive 1. So over 1, up 1. This is probably one of the most universal functions. I think they call it the identity function. Why do they call that? Well, y and x are equal to each other. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Okay, so as y goes up by 1, x goes up by 1 as well. The second set, they gave you 0, 8, 1, 6, 2, 4, 3, 2, and then 4, 0. So what's going on here? Well, in Word, looks like for every 1 to the right, you're going down 2. Again, 1 to the right, change in the height. Other way you could describe it, as y loses 2, x is gaining 1. So you're going 1 to the right, going down 2. We'll call that slope in the future. 1c, it gave you 3 and 0, 3 and 1, 3 and 2, 3 and 3, 3 and 4. This is a vertical line. And you cannot, if I haven't mentioned this enough, you cannot have vertical lines as a function. It simply does not work. What does that mean? That's the same thing as putting, here's a little function box here. If you put a 3 in and then you got a 1, a 0, a 2, a 3, a 4 in any order, okay? You're putting one number in and then more than one number comes out. That cannot happen. Plus, when you try to describe it, it's not changing at all to the right. And then is it going up or is it going down? I don't know. So it kind of fails this whole 1 to the right change in the height idea. But you still can describe it in words. You can say that x equals 3 for all y values. Again, vertical lines cannot be functions. Okay. I really like this one, number 2 right here. I'm going to zoom in a bit. I really like this number 2 where it says use the diagram below, copy and complete the table showing the relationship between the number of squares and the perimeter that they form. All right, let's cheat a little bit here. So 1, 2, 3, 4. There you go, 1 and 4. 1, 2, 3, 4, 5, and 6. I can't believe I skipped that one. There's 6. What about 3? If you don't see the pattern already, let's count it out. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. 3's got 8. I'm sorry this didn't really copy very well. I apologize for that. Let me try to split it up a little bit better. Here we go. Okay, what about 4? Well, you can draw a picture if you want. I'm going to. Why not? I'm not smart enough. I haven't figured out the pattern yet. Let's take a look here. Well, if I had 4 blocks, I'd probably have a perimeter of 4 up here, and then 1 and 1 on the sides. I'm pretty sure that's 10. Okay, I'm going to start being smart now. It looks like as the number of squares increase by 1, the perimeter is increasing by 2. All right, so now I'm going to cheat a little bit because it skips all the way to 10. Okay, so watch this. Every 1 that changes over here, you get 2 over here. So watch this. Going from 4 to 10, that's a plus 6 move. So that's a plus 6 move. Guess what? If it's a 1 to 2 ratio, plus 6 over here means plus 12 over here. So this should be 22. Okay, or I can draw a picture. If I had this pattern with 10 squares, I would have 10 on the bottom, 10 on the top. Make it 10, please. 1 and 1. 10, 21, 22. Okay, moving on. Oh, no. They give us 62 right here. How do we work backwards? Well, we can kind of reverse engineer what we did. So what's going to be the number of squares if we have 62 perimeter to spin? Well, as you can see, they all have something in common. They all have this common 1 and 1 over here. So we've already spent 2. So what's left? We have 60 left over to spend on the top and the bottom. How about we chop 60 in half? Okay, we'll make you 30. And we'll make you 30. Oh, 30 is our answer. Okay, if I wanted to be super smart, watch this. If I use the ratio idea, going from 22 to 62, that's plus 40. So if I jumped 2 over here for every 1 over there, and if I jump 40, that would be a jump of 20. And sure enough, it is. 10 plus 20 is 30. All right, now how do we make this, dude? How do we make the formula? If you haven't made the formula already, here's what you do. N represents the number of squares. If you've noticed, we were going to take the number of squares times 2. Okay, if you saw that, we took it times 3. We had 3 squares, 3 on top, 3 on the bottom. That's times 3. Excuse me, that's times 2. We had 4 on the top, 4 on the bottom. That's times 2. 10, 10 and 10. That's times 2. times 2. You take the number of squares times 2. Then you add that pesky extra 2 that every single one had. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and then 1, 2. Also known as the constant. Okay, so the change was 2 and the constant was 2. So 2n plus 2, and we're all done. Except for 3, 4, and 5. Okay, the amount of toothpaste in a tube decreases each time you brush your teeth. Identify the independent and the dependent variables in this relationship. Well, friends, you are human beings. So when you brush your teeth, okay, that is the independent variable. Okay, that's what you are doing. You, the humans, are independent human beings. You choose when and when not to brush your teeth. The amount of toothpaste has absolutely no control over itself. It depends on when you brush your teeth. So the amount of toothpaste would be the dependent variable. Okay, the amount of toothpaste is just sitting in there waiting until you do something. It depends on when you brush your teeth. So brushing your teeth, that's the independent variable, and the amount of toothpaste is the dependent. Okay, tell whether each set is an ordered pair. Is it a function? Well, where's my answers? Straight line, function, straight line, function. Ooh, vertical line, you are not a function. Sorry, function. You are not a function. You don't count. And speaking of straight lines, number 5, is that linear or nonlinear? Well, it's nonlinear. It is not linear because it is curved, so no curves allowed. Only straight lines. Okay, there you go. That's it, friends. That's 1 through 5. Peace out.